formulas that you should know. With the area of the triangle, the only reason that we come back to that when you've done that in the past is we're going to change the name of the dimensions that you normally use. So instead of length times width, we're going to use base times height, because the base and the height are pretty consistent throughout some of the other formulas. Okay, so your base and your height are your two dimensions of the rectangle. And just a little note here, and this goes through most of the formulas, or all the formulas that you're going to use. Base and height should be perpendicular. Okay, if you're taking two dimensions that are not perpendicular, they're not your base and your height. One of them might be your base, but the other would be the height. Okay, so you want to be careful with that. Now, the reason they start with the area of the rectangle is because the parallelogram has a nice little relationship, and if you understand the relationship to the rectangle, you've already got the formula. Okay, so if we were to take a parallelogram and we were to cut this piece off, that triangle right there. Okay, since these two sides are congruent, if we were to pick that up and slide it over to the other end, okay, you would have a rectangle with opposite sides congruent, because the parallelogram, that's one of the features, is opposite sides of parallelogram should be congruent. So simply taking this piece and sliding it over here just adds it on to this end instead of that end, and it would still be congruent, and these would be congruent, but you'd have the right angle here over there. So you'd basically have a rectangle as a result. So we can use the same formula that we call this the base, and we call that the height, and they are perpendicular. And our area is still base times height. Okay, so you've got the same formula for parallelogram that you do for a rectangle. Now, the reason they don't go through some of this earlier is you need some of the rules and such that you've learned from previous chapters occasionally to find those missing dimensions. And one of the things you might have to do is given that we have triangles involved here, you might have to do the Pythagorean theorem. Eventually in this chapter, you're going to have to use trigonometry to find some of the missing lengths that you need to calculate the area. Okay, so that's why it falls actually where it does after chapter 8. So we'll look at a couple examples. And you're going to want to get in the habit in this section of showing units. Without the units, you will be marked off a little bit. So in this one, you simply need to identify which piece is the base and which is the height. And if you go with what I said a moment ago, that they're perpendicular, you don't need the 4.5 at all. Okay, this would be your height, that would be your base. So the area is base times height. So that would be 4 times 5, or 5 times 4, which is 20. Now, since that is an area, we also get into a different set of units. These are no longer just inches, they are square inches. So when you're calculating areas, you want to make sure you're using square units. Okay. The other thing to be aware of is when you get a parallelogram that's kind of on the skinny side. Sometimes your dimensions will be outside of the figure. Okay, but they still have to be perpendicular. So in this case, what would you use as your base and your height? So 3.5 would be one of your dimensions, and 2 would be the other. So this would be considered the base, that would be the height. I mean, you're just going to multiply them, so it doesn't really matter, but area would be 2 times 3.5, so 7 square centimeters. Okay, now these are basic, but one of the things that I'm going to ask you to do, especially as we get into more involved formulas, is write the formula down before you plug anything in. It's a paper trail. It allows me to see if you're doing something wrong, what you're plugging in, which formula you're using. That can tell a lot, because if you're using the wrong formula, that's a problem. If you're plugging the wrong values into the formula, that's a problem. If you're getting it right but you're solving wrong, that's another issue yet. So it is very helpful with these to see what specifically you're doing, okay? Now the part of this that is a little bit new is finding a dimension, okay? This one seems to be one that people will struggle with if they struggle with any of this. So we're going to put the dimensions in a second. So with this, the key, I'm going to give you just a couple steps. You're going to find the area. Using base times height. That are given. And then you're going to use the area to find either the other base or height. Okay. Oops. So the question would be to find CF, right? So that would be your outside height. So we would start with the base and the height that we know that are perpendicular. Okay, so we're actually going to start with that pair, and we're going to find the area of the figure. So the area equals 12 times 10. So that would be 120. So that's what we did there. Now we're going to use the area to find the other base or height. But remember, you've got to use the two that are perpendicular. Okay, so why don't we call this x? So if the area is 120, then it shouldn't matter which pair of dimensions we use, right? So 120 should equal 13 times x also. Does that make sense? So you're going to divide out 13. So x would be approximately 9.2 inches. Now, if you want to do this all in one step, you could say the base times the height, or one base times height should be equal to the other base times height, right? So you could set it up all in one shot. So I could say 12 times 10 should be equal to 13 times x. You could do that also and set up one equation right off the bat. Back in a minute. All right, so we're going to try another one. Now, this one we're going to do this. Some of them you'll have will be in Word, and you're going to either sketch it out, or if you already know how to set it up, that's fine as well. So we have a parallelogram with sides 15 centimeters and 18 centimeters. The height corresponding to the 15 centimeter base is 9 centimeters. Find the height corresponding to the 18 centimeter base.
So that means just do the same thing you just did up there.
Just have to make sure, you use the right pair. Okay, so our area, what would we use to find our area to begin with? Would you use 15 and 18?
15 and 9.
Yeah, it says the height corresponding to the 15 centimeter base is 9. So 15 times 9 should give you your area. So 135. That should be the area of the parallelogram, and then using the other dimension, 18 times h should be 135 as well. So you're going to divide out your 18. So h should be about 7.5 centimeters. Okay, now again, if you wanted to set this up all in one shot, you could say 15 times 9 equals 18 times h, and you'll have one equation to solve for h. Okay, so you're basically setting each pair of dimensions, the product, equal to each other.